Hello everyone and welcome back to our channel. In today's video, we are going to talk through The Matter with Things, Our Brains, Our Delusions and the Unmaking of the World by Iain McGilchrist, published in 2021. There are 3 sections, and this is the first part of the summary. This book aims to challenge the dominant Western perspective that has shaped our understanding of reality. The author argues that we have misunderstood the nature of reality by relying on our brain's left hemisphere, which focuses on manipulating the world, rather than the right hemisphere, which comprehends it. The book explores the consequences of this misunderstanding, such as the havoc wrought on the world due to our lack of understanding. The author offers a new synthesis of philosophy and science that can lead to a richer and truer understanding of reality. They also suggest that relationships are more foundational than individual things and challenge the reductionist view of the world. The book encourages readers to question their assumptions and embrace a new perspective on reality. McGilchrist argues against the idea of true randomness and the concept of simplicity as a special case of complexity. He states that complexity is the norm, while simplicity is achieved by disregarding the vast reality that surrounds it. He also proposes that inanimacy should be seen as the limit case of animacy, and the actual as the limit case of the potential. Linearity is a limit case of nonlinearity, and discontinuity is a limit case of continuity. Total independence is an imaginary construct and purpose is inherent in the universe. The chapter concludes by discussing the author's aim to offer a new perspective on fundamental aspects of the cosmos and their relevance to current global crises and Western culture. The book explores the concept of existence and how it is shaped by our interactions and attention. It argues that existence is not a fixed entity but rather a constantly evolving process that emerges from the continuous interaction between individuals and their environment. This applies not only to music but also to all aspects of life. McGilchrist emphasizes the interconnectedness of everything and the impact that each individual has on the world, even if it may seem small in comparison. He also discusses the role of attention in shaping our perception of the world and the moral implications of our choices in how we attend to it. The difference between the hemispheres of the brain is also mentioned, with attention being identified as a key factor in understanding this distinction. Existence is a dynamic and complex flow that can only be truly known through our active participation and attentive response to it. The author discusses the hypothesis that the brain's divided structure allows us to attend to the world in 2 incompatible ways simultaneously. This division between the hemispheres has implications for various aspects of human experience, including cognitive and emotional differences. The right hemisphere is responsible for open, sustained, vigilant attention, while the left hemisphere focuses on narrow, sharply focused attention. Attention is not just a cognitive function, but a disposition that alters whatever it encounters. The way we attend to something determines how we experience it. Different ways of attending produce different understandings of reality, none of which can be considered the real way. The reductionist view that seeks to explain human experience solely through physical processes is too limited and leaves out important aspects of our humanity. McGilchrist's book highlights the asymmetrical nature of brain hemispheres in both animals and humans, with each hemisphere paying different types of attention to the world. The left hemisphere, LH, is associated with narrow, focused attention, while the right hemisphere, RH, is more open, vigilant, and interested in understanding the whole. The LH is focused on manipulation and details, whereas the RH is concerned with the bigger picture and what is new. The LH seeks certainty and tends to see things as isolated, while the RH embraces ambiguity and sees the interconnectedness of things. The LH prefers the familiar, while the RH is more receptive to change. These differences in attention shape the way humans perceive and interact with the world, impacting language, humor, and understanding. The left hemisphere, LH, tends to categorize based on the presence or absence of a particular feature, while the right hemisphere, RH, categorizes using a family resemblance approach and sees the overall gestalt. The LH is better at fine analytic sequencing and language, while the RH excels at understanding body language, emotion, and empathy. The LH sees things as they are represented, while the RH sees things as they are fresh and unique. The LH tends to have an optimistic and unrealistic view, while the RH is more realistic and pessimistic. Both hemispheres have distinct and coherent ways of understanding the world, and the understanding of this duality is important for recognizing our strengths and limitations as human beings. All experience we have in life is filtered through the brain, which shapes and constrains our perception of the world. Although there are similarities between the two brain hemispheres, there are also distinct differences. The hemispheres work together in everything we do, much like a surgical team working in tandem. However, they have different roles and functions, contributing to the complexity of consciousness. While there is localization of function within the brain, neuroscience is increasingly recognizing the importance of complex widespread networks. The dichotomy between the hemispheres is not absolute, and there is overlap between their functions. The differences between the hemispheres are not solely at the level of mechanism, but also at a phenomenological level where they lead to different perspectives and ways of experiencing the world. The hemispheres can sustain independent consciousness and possess separate inner worlds. McGilchrist mentions research done on split brain patients that suggests each hemisphere experiences its own private sensations and thoughts that are inaccessible to the other hemisphere. He highlights the work of various researchers who support the idea that the hemispheres underwrite different aspects of personality and cognition. They argue against the prevailing belief that hemisphere differences are not relevant to normal brain functioning and stress the importance of recognizing these differences. He also addresses the need for a balance between the hemispheres and how an over-reliance on left hemisphere thinking can lead to a narrow perspective. They emphasize the importance of philosophy and understanding the implications of neurological facts in science. The author explores the nature of reality and the human mind's capacity to understand it. Reality is an unending process that cannot be fully grasped. He argues against the notion that reality is whatever we think it is and emphasizes the importance of being aware of the limits of our understanding. Hemisphere hypothesis suggests that the right hemisphere of the brain is better at understanding metaphor and the whole picture, while the left hemisphere focuses on analyzing the parts. The author proposes that understanding reality requires considering both hemispheres and examining different paths to truth, such as science, reason, intuition, and imagination. Reality is more complex and mysterious than we can fully comprehend. The autonomic nervous system, which controls subconscious bodily functions, is divided into the sympathetic and parasympathetic systems. The brain also has pairs of opponent processes along the top to bottom, front to back, and lateral axes. Lateral asymmetry, specifically the right-left divide, is present in the nervous systems of various species, including primitive organisms like sea anemones. With the development of mammals, three important aspects of the brain evolved: the neocortex, responsible for higher conscious functions, the corpus callosum, enabling communication between hemispheres, and the frontal lobes, involved in decision-making. The neocortex expanded to process more sophisticated sensory information, while the corpus callosum facilitated interhemispheric communication. As brains grew, cortical areas became more specialized, and the corpus callosum differentiated and specialized in order to efficiently transmit necessary information. The callosum allows for communication and integration between the hemispheres in certain areas, such as sensory and motor information processing, but not in others, such as complex cognitive functions. The author highlights the role of inhibitory interneurons in maintaining balance and independence between the hemispheres. He also explores how the asymmetry and specialization of the brain affects the size and function of the corpus callosum. Additionally, he discusses the relationship between the frontal and posterior cortex in each hemisphere, emphasizing their roles in perception, integration, and decision-making. Overall, suggesting that the coordinated but independent functioning of the two hemispheres is crucial for optimal brain function. The left hemisphere tends to dominate and control attention, leading to a more focused and narrow view of the world. On the other hand, the right hemisphere is more in touch with reality and takes in a broader and more holistic view. Damage to the left hemisphere may result in deficits in language and motor functions, but the world remains recognizable. However, damage to the right hemisphere can lead to a loss of empathy and a range of cognitive and emotional impairments, significantly impacting the individual's perception of the world. The book also highlights the phenomenon of attentional blindness and hemineglect, where individuals fail to acknowledge or perceive stimuli in their left visual field due to the dominance of the left hemisphere's attention. Patients with neglect, caused by right hemisphere damage, not only neglect one half of the world, but also narrow their attention to the remaining half. Additionally, the right hemisphere's attention is flexible, while the left hemisphere's attention is sticky. Following right hemisphere damage, patients may become fixated on objects in their right visual field and have difficulty disengaging from them. Visual neglect is not caused by this abnormal fixation towards the right. Attentional deficits also affect the perception of time. The left hemisphere, which is responsible for attention, constitutes the world and ceases to acknowledge what it does not attend to. Patients with neglect may lack insight into their deficits and have difficulty imagining the possibilities beyond their attentional focus. An experiment where patients were asked to imagine standing in a square and describe the buildings around them. Interestingly, the patients could accurately describe the buildings on the right side of the square but were unable to recall the buildings on the left side. When asked to imagine standing at the other end of the square, the patients now accurately described the buildings on the left side but omitted the buildings on the right. This demonstrates that attention is involved in not just seeing, but in the formation of our perception of the world. The right hemisphere is responsible for integrating and perceiving the flow of time, while the left hemisphere focuses on discrete instances and fragments of space and time. Damage to the right hemisphere can lead to distortions in both space and time perception, resulting in phenomena such as palinopsia and a loss of depth perception. The left hemisphere tends to flatten and schematize space, and its drawings often lack depth and detail. Overall, the study highlights the crucial role of both hemispheres in our perception of the world and the complex interplay between attention, space, and time. McGilchrist's book discusses the effects of right hemisphere damage on perception, specifically on depth perception, time perception, and motion perception. It notes that patients with right hemisphere damage may experience a loss of depth perception, resulting in a perception of a flat, two-dimensional world. They may also have difficulties perceiving motion and inferring three-dimensional structure from movement. The author also highlights the role of the right hemisphere in attention, suggesting that its damage can lead to disturbances in attentional field, such as experiencing slow motion at the focus and accelerated motion at the periphery. Furthermore, he explores the emotional and affective aspects of right hemisphere damage, noting that patients with right hemisphere strokes often exhibit a lack of affect and emotional depth, while patients with left hemisphere strokes may have severe emotional reactions. Patients with right hemisphere damage fail to acknowledge the existence of left-sided items or neglect their left-sided vision. These patients exhibit a cognitive neglect of information, but also display a denial of experience known as anosognosia. Anosognosia is characterized by an unwillingness to acknowledge a deficit, which is usually consequent on right hemisphere damage. In addition to neglect and anosognosia, patients with right hemisphere damage also exhibit confabulation, which is the invention of stories to fill in gaps in their memory or understanding. This confabulation is often held with total conviction, even when the story is implausible. These deficits, including asomatognosia and somatoparaphrenia, highlight the role of the right hemisphere in our sense of self and our ability to accurately perceive the world. Somatoparaphrenia is a condition where individuals with right hemisphere brain damage deny ownership or connection to their affected limb. They may believe that the limb belongs to someone else or is an inanimate object. This condition is often accompanied by confabulations and delusions, which are resistant to correction. Reduplicative paramnesia, where patients believe that there are multiple copies of important aspects of their world, such as cities or people. The right hemisphere plays a crucial role in perceiving the whole and maintaining a sense of self, and damage to this hemisphere can lead to fragmentation and a focus on individual parts rather than the overall picture. Perception is connected to attention and thinking. The book highlights the differences between the left and right hemispheres of the brain in terms of perception. The left hemisphere tends to have a restricted and precise attention, focusing on parts rather than wholes, while the right hemisphere has a broader attention, perceiving and integrating information from multiple sensory modalities. The author also discusses the importance of perception in understanding and experiencing the world, emphasizing the role of the right hemisphere in perceiving the world as a whole. Perception is not just a passive reception of sensory information, but an active and participatory process. The right hemisphere of the brain has long been recognized as better at perception. This understanding dates back to ancient Greek physicians who believed the right hemisphere was specialized for perception. Recent research has confirmed this insight, showing that the right hemisphere is superior at various aspects of vision, such as stimulus detection, depth perception, size estimation, orientation matching, and pattern recognition. It is also better at color perception and brightness sensitivity. The right hemisphere has a more nuanced and thoughtful approach to processing information, making it more accurate in situations where there is ambiguity or uncertainty. In contrast, the left hemisphere is faster in processing clear and familiar stimuli. In addition to visual perception, the right hemisphere also plays a crucial role in auditory, olfactory, and tactile perception. Overall, the right hemisphere provides a more holistic and contextual understanding of the world, while the left hemisphere focuses on the details and categories. The book also discusses the phenomenon of perceptual rivalry and the role of the right hemisphere in switching between different interpretations of visual stimuli. Perceptual rivalry occurs when there are conflicting interpretations of a bistable image, such as Schrodinger's stairs. The right hemisphere is primarily responsible for engaging in this competition and allowing for switching between different percepts. EEG and fMRI studies have shown that the right inferior parietal cortex is important for facilitating perceptual shifts. Patients with right hemisphere damage often have difficulties with perceptual organization and maintaining a coherent sense of self. Visual hallucinations and distortions are more common after right hemisphere damage, while left hemisphere damage tends to affect emotional value. The right hemisphere is also thought to play a role in awareness of the physical self and the integration of contextual information. McGilchrist introduces various cases of visual distortions following brain injuries or disorders. These distortions mainly affect the perception of faces and can include hemimicropsia, perceiving one side of an object smaller than the other, prosopometamorphopsia, distortion of faces, and Alice in Wonderland syndrome, distortions of body perception and time. In most cases, these visual distortions occur after right hemisphere lesions, as face perception is largely dependent on the right hemisphere. However, there have been a few cases where left hemisphere dysfunction also caused prosopometamorphopsia. These visual illusions and hallucinations are not only observed in cases of brain injuries but are also common in patients with schizophrenia. The author discusses various pathologies related to perception, judgment, and belief. He highlights the role of the right hemisphere in primary perception and reveals that perceptual distortions and hallucinations are strongly associated with right hemisphere dysfunction. Delusions, on the other hand, are predominantly linked to right hemisphere damage or dysfunction. The left hemisphere, when not deluded, appears to lack guidance and relies on the right hemisphere to anchor it to reality. Delusions are more likely to occur when the left hemisphere's tendency to explain goes awry, leading to excessive inference making and premature conclusions. This propensity for closure combined with the absence of reliable experience without a functioning right hemisphere contributes to delusion formation. Overall, the right hemisphere plays a crucial role in perceiving reality accurately, while the left hemisphere's overactivity or underactivity can result in delusions. Right hemisphere damage often results in delusional disorders, while left hemisphere damage is less likely to cause psychosis. Right hemisphere damage is commonly associated with neglect of the left half of space, whereas left hemisphere damage may produce similar deficits in the right half of space, though less severe and transient. Right hemisphere dysfunction is linked to various delusional disorders, such as anosognosia, denial of a deficit, prosopagnosia, inability to recognize faces, delusional misidentification, paranoia, Othello syndrome, delusional jealousy, de Clermont syndrome, erotomania, mirror agnosia, Cotard's delusion, belief in being dead, and Capgras syndrome, belief that loved ones have been replaced by imposters. Specific brain hemisphere dysfunction is associated with various neurological conditions. Some of these conditions include lycanthropy, delusions of infestation, response to next patient syndrome, alterations in body perception such as anorexia nervosa and phantom limb sensations, autoscopy and hotoscopy, xenomelia, misoplegia, choro and DHAT, and insight into illness. Right hemisphere lesions are often associated with these conditions, while left hemisphere dysfunction is linked to depression. The right hemisphere supports the body schema, and its abnormalities can lead to disorders such as anorexia nervosa and misoplegia. Insight into illness is largely right hemisphere dependent, and depression can increase awareness of one's illness. Previous studies suggested that depression was more common after left hemisphere stroke, but recent research does not support these findings. Lesion location is not associated with depression, although there is a weak association with left frontal stroke. A meta-analysis found no overall difference in depression rates between left and right hemisphere stroke. However, a systematic review found an association between right hemisphere stroke and depression in the subacute post-stroke phase. Depression and time perception are both right hemisphere mediated. The left hemisphere tends to be unrealistic and overly optimistic, lacking insight into its own limitations. Right frontal damage can cause fatuous optimism, while left frontal damage can lead to confabulation and false memories. The right hemisphere is more cautious and provides a more veridical account of memories. Overall, there is no straightforward relationship between laterality of stroke and developing depression. Right hemisphere of the brain is more involved in certain aspects of memory and thinking, specifically related to autobiographical memories and implicit motivations. The left hemisphere, which is often associated with language and cognition, may not be reliable when it comes to self-perception and truth. Magical thinking, which involves belief in invalid forms of causation. While it is not clear whether magical thinking is associated with the right or left hemisphere, it is suggested that certain levels of magical thinking may be normal and functional. The book highlights the existence of sex differences in brain lateralization and the potential influence of hormones on functional asymmetry. Sex differences in brain asymmetries contribute to complementary patterns of strengths and weaknesses. In various areas such as decision-making, language, spatial orientation, face perception, and creativity, men tend to rely more on the right hemisphere while women employ more left hemisphere processing. Men also exhibit greater right hemisphere activation in tasks involving global attention, while women excel in local processing. These differences are influenced by hormones, with testosterone favoring global strategies and progesterone favoring local strategies. There are also differences in memory, with men recalling the gist of an emotional story while women remember the details. Additionally, males tend to have better spatial abilities while females excel in language-related tasks. However, it is important to note that these differences are not absolute and there is significant overlap between sexes. Deduction is the process of uncovering implicit meaning and integrating it with existing knowledge. The right hemisphere plays a larger role in deduction, while the left hemisphere tends to jump to hasty conclusions based on what seems likely. The left hemisphere relies on familiar situations and heuristics, while the right hemisphere engages in more formal reasoning when faced with unfamiliar situations. The right hemisphere is also responsible for detecting inconsistencies and conflicts between beliefs and logical inferences. It acts as the bullshit detector, avoiding both nonsense and dismissal of rational arguments. The left hemisphere tends to be rigid, maintaining hypotheses even when faced with conflicting evidence. The right hemisphere is better at dealing with uncertain and incomplete information. Overall, both hemispheres contribute to logical thinking, but their strengths and approaches differ. After damage to the left hemisphere, individuals may experience difficulties in reasoning and understanding the real-world meaning of procedures. The left hemisphere tends to jump to conclusions and overgeneralize, often constructing potential pasts instead of the true past. It is more prone to delusional thinking and struggles with incomplete or contradictory information. In contrast, the right hemisphere excels in pattern recognition, context understanding, and making logical inferences from implicit or unfamiliar circumstances. It is more sensitive to the nuances of language and has a better ability to revise assumptions. Overall, judgments made by the right hemisphere are more reliable and veridical. Ultimately, damage to the left hemisphere can impact our capacity for effective utilization and manipulation of the world. Speech and language development in humans stem from the left hemisphere of the brain, which is also responsible for controlling the movement of the right hand. Language is believed to have developed from gestures, as it is found that the speech area of the brain is activated during grasp and manipulation of objects. Similarly, hand movements are impaired when verbal fluency is restricted. Patients born without arms can still experience phantom upper limbs, suggesting the existence of an innate morphogenetic schema. Left hemisphere damage can result in motor impairments of the right arm and hand, as well as language impairments. It can also lead to difficulty in using everyday objects and tools, known as ideomotor apraxia. The right hemisphere, on the other hand, is associated with exploration rather than grasp. Language, ultimately, is a way of mapping the world and manipulating symbols to see beyond immediate experience. It can be likened to a map, where words represent aspects of reality in the left hemisphere's world, while in the right hemisphere's world, words are fused with the aspects they represent. Language, like money, derives its value from an underlying reality and is inherently metaphoric in nature. Metaphor, prosody, intonation, and pragmatics, real-world context, are primarily processed by the right hemisphere, while semantics and syntax are primarily processed by the left hemisphere. The left hemisphere has a larger vocabulary and more complex syntax, allowing for a deeper understanding of the causal relationships between things. The author also explores other functions of the left hemisphere, such as body part recognition and language representation. He highlights the challenges faced by individuals with left hemisphere damage, including difficulties in writing, calculating, right-left orientation, and finger naming. Overall, the left hemisphere's strength lies in manipulating data efficiently, but it struggles with understanding real-world meaning and maintaining a grasp on reality without the assistance of the right hemisphere. When the spontaneous excitability of the cortex occurs, it may indicate that there is underlying damage to the cortex, affecting its normal functioning. While it can be difficult to interpret these cases with certainty, additional evidence can sometimes provide a clearer explanation. In specific cases where right hemisphere lesions were present, individuals experienced heightened awareness and a sense of intensified reality. Artificial stimulation of the affected area in one case resulted in a heightened sense of awareness to smells, sounds, and visual objects. Left hemisphere lesions, on the other hand, were associated with a feeling of detachment and a sense that the world was unreal. Damage to the left hemisphere is less likely to cause distortions of reality compared to damage to the right hemisphere, but it cannot be completely excluded from the picture. Emotional connectedness, empathy, and a sense of reality are associated with right hemisphere function, while the left hemisphere is more involved in anger and other left lateralized emotions. There is evidence to suggest that the right hemisphere is crucial for theory of mind and empathy, as damage to this hemisphere impairs the ability to understand and empathize with others. People with right hemisphere damage often disregard the feelings and needs of others. The mutual gaze between mother and infant, mediated by the right orbitofrontal cortex, is crucial for the development of a stable and secure individual. Self-awareness, empathy, and identification with others depend on right hemisphere resources. Mirror neurons, active when performing an action and observing another perform the same action, play a role in empathy and imitation. While mirror neurons are present in both hemispheres, the right hemisphere is more involved in perceiving non-instrumental actions and in understanding the motivations behind them. The right hemisphere is superior in receiving and understanding emotions, including facial expressions and body language. The left hemisphere tends to process anger and disgust, while the right hemisphere is involved in social bonding and empathy. People with right hemisphere damage, such as those with prosopagnosia, inability to recognize faces, show difficulty in recognizing facial expressions and body language, as well as diminished expressivity in their own facial expressions and gestures. The right hemisphere is also involved in understanding and generating humor, irony, and sarcasm. Right hemisphere damage impairs the ability to comprehend narratives, make appropriate inferences, and discriminate between fantasy and reality. Additionally, patients with right hemispherectomy or right parietal damage may experience shallow affect, lack of imagination, and diminished personal and emotional memory. Overall, the right hemisphere plays a critical role in social perception, emotional expression, and understanding narratives. Patients with damage to the right inferior parietal cortex demonstrate social deficits, including avoiding eye contact and lacking emotional expression in their voice. They may have difficulty recognizing variants in intonation and recognizing themselves in old photos. Despite these impairments, their formal knowledge and cognitive abilities in the domain of thinking about inanimate objects remain intact. In contrast, patients with left hemisphere damage have severe speech disturbances, but their facial expressions, gestures, and intonation remain intact. The left hemisphere is better able to inhibit the right hemisphere than vice versa. Split brain subjects who have undergone a callosotomy often experience intermanual conflict, with the left hand seeming mischievous or rebellious because it does not align with the left hemisphere's script. The right hemisphere's understanding of metaphor and ability to make sense of an utterance as a whole is greater than that of the left hemisphere. The right hemisphere is also more adept at discriminating unfamiliar meaningful expressions and plays a significant role in music. The left hemisphere, on the other hand, struggles with understanding human meaning. It has difficulty with pragmatics, interpreting metaphorical language, and grasping non-literal meanings. The left hemisphere favors denotative meanings and cliches, while the right hemisphere is better at understanding fresh metaphors. Activity in the right hemisphere is crucial for comprehending non-literal meaning, such as metaphor, and for understanding context and implicit information. The right hemisphere also plays a role in emotional expression and receptivity, empathy, and understanding the intentions of others. Contrary to popular belief, McGilchrist's book argues that the left hemisphere is not the source of intelligence but rather specializes in following familiar procedures. Intelligence is described as a general mental capacity that involves reasoning, problem-solving, abstract thinking, and learning from experience. Overall, the evidence suggests that the right hemisphere is superior in many aspects of social and emotional understanding, as well as in certain aspects of intelligence. The author highlights the role of the right hemisphere of the brain in fluid intelligence, GF, and the importance of integration and connectivity among various brain regions. They discuss studies that suggest a strong association between GF and right hemisphere activation, especially in tasks involving pattern recognition and problem solving. He also mentions the Flynn effect, which refers to the increase in IQ scores over time, but argues that this increase may not necessarily reflect a true increase in intelligence. The author presents evidence of a decline in intelligence test results in recent years, indicating a reversal of the Flynn effect. Research conducted by Flynn reveals that there has been a decline in IQ scores in the United Kingdom, particularly among the top performers. The drop in scores may be attributed to the influence of youth culture, which emphasizes computer games over other forms of stimulation like reading books and engaging in conversation. The decline in cognitive performance at the highest level is concerning because it indicates a reduction in the number of individuals who possess the ability to think abstractly and engage in deductive logic and systematic planning. Furthermore, the decline appears to be more pronounced in areas that do not heavily rely on general intelligence, suggesting that the Flynn effect, which initially showed an increase in IQ scores, was primarily driven by practice and test-specific skills rather than actual intelligence. Other factors contributing to the decline in IQ scores include teaching to the test and a shift toward a more analytical and hypothetical thinking style rooted in the scientific worldview. The decline is particularly evident in spatial ability, a test that relies heavily on right hemisphere thinking. The writer discusses the decline in intelligence in highly industrialized Western countries and how this decline is due to environmental factors in society. He also explores the concept of creativity and its importance in all living creatures, but particularly in humans. The three phases of the creative process, preparation, incubation, and illumination, are described, noting that the process relies on unconscious processes, flexibility, and openness, which are characteristics more commonly associated with the right hemisphere of the brain. The book also analyzes the cognitive requirements for creativity, including generative requirements, divergent thinking, permissive requirements, not inhibiting creative potential, and translational requirements, carrying the creative impulse forward. Creativity requires more than just intelligence or knowledge. It requires the ability to make connections between seemingly unrelated ideas. This is a rare characteristic that not everyone possesses. The process of making these connections is often unconscious and requires a certain level of daring and openness to new possibilities. Creativity is best achieved when there is a broad understanding of different domains and a willingness to explore and synthesize new ideas. Linear thinking and analytic approaches alone will not lead to creativity. The right hemisphere of the brain plays a crucial role in creativity, as it is more open to new and unexpected ideas. However, creativity cannot be forced or controlled. It is a process that unfolds naturally and is hindered by over-control. In the pursuit of creativity, it is important to relax, let go of preconceptions, and be open to uncertainty. The translational element of creativity requires persistence, rationality, and courage to bring an insight to completion. Ultimately, both hemispheres of the brain are involved in the creative process, but they approach it in different ways. Creativity is not a fixed entity, but rather a way of approaching the world. It involves using language, mathematics, drawing, designing, building, or composing in a creative manner. The two hemispheres of the brain play different roles in creativity. The right hemisphere is linked to the divergent element of creativity, which involves making analogies and connections and opening up to new possibilities. The left hemisphere, on the other hand, excels in following rules and procedures. Creativity involves two phases: exploration and evaluation. It is not a purely logical process, but requires intuition and insight. Creativity cannot be forced or predicted, but comes from the unconscious mind. It is not a random process, but guided by patterns and forms that are partly seen. The right hemisphere is believed to play a crucial role in creativity, although it is not the only factor at play. Insightful moments, or aha moments, typically involve a change in understanding and are triggered by inconsistencies and contradictions. The left hemisphere tends to preserve existing models and dismiss anomalies, while the right hemisphere acts as an anomaly detector and encourages change and exploration. The right hemisphere is more adept at making connections, seeing patterns, and integrating different strands of thought. It is also more in touch with personal experiences, emotions, and the body. The right hemisphere is associated with intuition and creativity, while the left hemisphere is more dominant in tasks that require analytical thinking and language processing. Lesion studies support the role of the right hemisphere in creativity, showing that injuries to the right hemisphere impair flexibility, originality, and the ability to break away from rule-based thinking. McGilchrist discusses the impact of strokes on artists and their artistic abilities. In cases of right hemisphere strokes, artists may experience difficulties in spatial perception, neglect of certain visual elements, and a loss of depth and flow in their artwork. However, it is not necessarily indicative of a loss of creativity, as these distortions can align with modern art styles. On the other hand, left hemisphere strokes tend to leave artistic talent intact or even enhanced, despite motor difficulties. Several artists who suffered left hemisphere strokes were able to continue or improve their artistic production, demonstrating their resilience and adaptability. Overall, the relationship between strokes and artistic expression is complex and varies depending on the individual. The author introduces several cases of painters and composers who have experienced left hemisphere strokes and how it has affected their artistic abilities. In the case of painters, changes in style and content were observed after the stroke, often resulting in an increase in emotional and artistic intensity. Some painters also improved in technique as their dementia progressed. On the other hand, composers who suffered left hemisphere strokes continued to create music, and in some cases, their creativity even increased. However, there is limited evidence of composers experiencing right hemisphere strokes and its impact on their artistic abilities. Overall, while both hemispheres are involved in the creative process, there seems to be a specialization of the right hemisphere for visual creativity and the left hemisphere for musical creativity. In one case, a composer who suffered a right hemisphere stroke was able to continue teaching and conducting but struggled to compose music. Another composer lost interest in composing after a right hemisphere stroke. The tragic case of Maurice Ravel, who had a degenerative brain disease, resulted in him losing his ability to speak and translate his musical ideas into music. However, he was still able to hear music in his head. The author also mentions poets who continue to write after suffering strokes, and how certain brain stimulation techniques have shown to enhance creative problem-solving abilities. It concludes that creativity is influenced by different patterns of brain activity and that reducing left hemisphere dominance can enhance creative thinking. Insight solvers tend to give up if they are unable to find a solution before the deadline, while analytic solvers often guess incorrectly, offering the hypothesis they were evaluating at the time. EEG and neuroimaging studies suggest that there is greater activation in the right hemisphere during creative tasks, particularly in divergent thinking and insight tasks. However, there is a debate whether creativity is best achieved through cooperation or independence between the hemispheres. Some argue that interactions between the left and right hemispheres are crucial for integrating different cognitive abilities, while others suggest that relative hemispheric independence is associated with higher creativity. McGilchrist also challenges the notion that convergent thinking, which focuses on finding the one correct answer, is creative, and provides examples of how creativity involves unexpected connections and insights. Aslow discusses the importance of relaxation and incubation in the creative process, highlighting the need for creative minds to find moments of relaxation and recharge in order for new ideas to form and develop in the unconscious mind. The examples of composers like Bach, Mozart, and Handel are used to demonstrate how creativity often arises from unconscious or divergent thinking rather than following established procedures. The author challenges the idea that creative insights are solely a result of conscious calculation or following rules. He emphasizes the importance of intuition and inspiration in the creative process and argues against the assembly line theory of creativity. Additionally, the writer criticizes the attempt to categorize creativity into neat divisions and argues that creative thinking is a complex phenomenon that cannot be easily defined or circumscribed. McGilchrist discusses the relationship between creativity and mental illness. He argues that there is evidence to suggest a strong connection between the two, as many creative individuals throughout history have been known to have mental health issues. For example, Aristotle observed that many outstanding individuals in fields such as philosophy, statesmanship, poetry, and the arts were melancholic. McGilchrist also cites modern studies that have found high rates of mood disorders, such as depression and bipolar disorder, among creative individuals. Furthermore, certain mood changes, particularly those that promote activity in the right frontal cortex, may be associated with increased creativity. McGilchrist cites various studies that found higher rates of mood disorders among poets and increased rates of mental illness among comedians. He suggests that there may be a connection between creativity and mental illness, potentially related to the use of language, the right hemisphere of the brain, and the ability to transcend ordinary limitations. However, the timing and degree of affective disorders matter, as extreme expressions of mania or depression can inhibit creativity. The writer also explores the genetic factors and induced mood states that may influence creativity. Ultimately, it concludes that there may be a difference between everyday creativity and the genius-level creativity of individuals like poets and highly creative geniuses. The mad genius paradox suggests that while everyday creativity can improve satisfaction and enjoyment of life, pushing boundaries in creativity may come at a cost. The author also highlights the distinction between averagely creative individuals, who tend to engage primarily the left hemisphere in creative tasks, and highly creative individuals, who tend to engage the right hemisphere. The relationship between intelligence, creativity, and mood disorders is also explored, with studies indicating that higher intelligence may be associated with a higher risk of bipolar disorder and depression among gifted individuals. Additionally, he introduces the insights gained from studying individuals with brain hemisphere imbalances, such as schizophrenia and autism, and their parallels with right hemisphere deficits. The author suggesting that a potential similarity between the way of being in the world for individuals with schizophrenia and the modern culture of today. Findings from the neurological literature suggest that schizophrenia shares similarities with right hemisphere damage. Both groups of individuals demonstrate visual distortions, hallucinations, and delusions. They also have impairments in perceiving and recognizing bodies, bodily movements, and their own faces. There are several common characteristics between the two groups, including emotional indifference, lack of initiative, diminished expressivity, difficulty with comprehension and generation of narratives, problems with context and meaning, limited expression and interpretation of emotion, and inflexibility in views and behavior. Both groups struggle with Gestalt perception, sustaining attention over time, and seeing the whole pattern. Schizophrenics and right hemisphere damaged individuals also share a lack of common sense and a tendency to jump to conclusions. Structural abnormalities in the right hemisphere, particularly in frontal and parietal areas, are associated with hallucinations, disturbances of the self, and delusions in schizophrenia. Furthermore, gene expression differences in the right frontal pole have been linked to schizophrenia. In both schizophrenia and autism, there is a loss or reversal of normal hemispheric asymmetry in terms of both structure and function. There is a correlation between the severity of disorganization symptoms in schizophrenia and the loss of normal brain asymmetry, particularly in areas responsible for language. This loss or reversal of asymmetry affects the differentiated functioning of the hemispheres, with the left hemisphere's linguistic and conceptual functioning impaired by the intrusion of right hemisphere activity and vice versa. In autism, there are parallels with right hemisphere deficit syndromes, including difficulties in global attention and integration of contextual information. Abnormalities in the structure and function of the right hemisphere are increasingly reported in autism spectrum disorders, with reduced lateralization, decreased white matter conductivity, and abnormal functional connectivity observed. Congenital disruption of the corpus callosum, which is common in autism, suggests a major risk factor for developing the disorder. Any alterations in the efficacy of neuronal connections carried by the corpus callosum can directly affect the balance between the hemispheres of the brain. Impairment of the right hemisphere's ability to inhibit the left hemisphere could lead to functional interference, particularly for the right hemisphere. Cases of early unilateral brain damage, epilepsy, or hemispherectomy in childhood have shown that the right hemisphere aspects tend to be squeezed out in favor of the left hemisphere. The brain is a highly interconnected system, and even seemingly circumscribed lesions can have widespread effects due to interconnectivity. Schizophrenic and autistic individuals often report a subjective sense of hemisphere imbalance, suggesting dysfunction in both hemispheres rather than localized impairment. These findings underscore the importance of considering the role of hemisphere imbalance in understanding mental abnormalities. In schizophrenia, individuals lose their sense of the whole and perceive the world as fragmented and disconnected. The loss of a sense of direction and purpose hinders their ability to experience time and music. They struggle to perceive the whole and instead focus on isolated parts. This fragmentation also affects their perception of the body, causing a disconnection and alienation. Consequently, individuals with schizophrenia experience a loss of identity and struggle to form relationships with others. This fragmentation is not exclusive to schizophrenia but can also be seen in the modern world, where individuals may feel detached, powerless, and lacking a sense of identity. The author describes the plight of modern humanity as exemplified in the writings of modernism. He discusses the loss of connection with the world, both in the present and the future, resulting in a routine and repetitive existence. He also highlights the loss of creativity and the experience of life, leading to a sense of separation and unreality. Schizophrenia affects perception, causing a disconnection from the world and objectifying oneself and others. The schizophrenic mind flattens reality and sees objects as disconnected entities. Language used by schizophrenic individuals tends to be abstract and focuses on static aspects of experience. Overall, McGilchrist suggests that our modern world, with its aversion to life and preference for inanimate objects and words, mirrors aspects of schizophrenia. In schizophrenia, there is a loss of vital contact with reality, leading individuals to see themselves and the world as lifeless and mechanical. The sense of flow and connection is replaced by a fragmented and static perception. For schizophrenic patients, the world becomes a stream of external stimuli that they can only juxtapose, lacking the ability to integrate and understand the dynamic nature of life. They may describe themselves as machines or robots, feeling like automatons with no agency or emotions. This devitalization extends to their perception of others, who appear as lifeless beings or dolls. The mechanistic worldview that pervades society reinforces these distorted perceptions, blurring the boundaries between humans and machines. This emphasis on objectification and reductionist thinking exacerbates the disintegration and detachment experienced in schizophrenia. The author explores how schizophrenic individuals often appear to inhabit the uncanny valley, where it is uncertain whether something or someone is alive or dead, real or unreal. He also examines the tendency of schizophrenic individuals to have an aversion to nature and a preference for the artificial and man-made. He suggests that there is a reliance on logic and a loss of intuitive understanding in schizophrenia, with an emphasis on procedure over meaning. Schizophrenic patients often experience a loss of meaning and doubt everything, including their own actions and possessions. They become fixated on attaining certainty and literal-mindedness, struggling to understand metaphor and abstract concepts. The hyper-consciousness that characterizes the modern world also inhibits their ability to tap into intuitive wisdom and leads to a sense of everything needing to be planned and checked beforehand. Schizophrenic individuals also experience a breakdown in the sense of flow and continuity, causing every movement and action to require careful consideration and concentration. They also often perceive reality as mere representation or imitation rather than true experience. Overall, the author highlights the similarities between the symptoms of schizophrenia and the effects of left hemisphere dominance. He also discusses the concept of freezing time and the need for constant representation in the left hemisphere's mode of being. He refers to the experiences of schizophrenic individuals who often have a sense of time standing still due to the same thoughts and mental content circulating repetitively. The idea of constantly recording and representing experiences is compared to Descartes' notion that the world must be constantly reconstructed or it disappears. The writer also mentions the role of record-keeping in bureaucracy and the modern obsession with photographs as a means of preserving memories. He explores the detrimental effects of freezing time and the inability to experience the flow of life. Additionally, he touches on the difficulties autistic individuals face with broadening focus and their tendency to measure and count rather than experience. He emphasizes the importance of narrative in understanding human meaning and the difficulties of those who cannot grasp implicit meaning or appreciate the power of spontaneous narratives. McGilchrist explores the effects of neglecting the right hemisphere of the brain, specifically in terms of understanding and making sense of the world. He highlights the discrepancies between the left and right hemisphere, noting that the left hemisphere is unreliable and susceptible to falsehoods. The left hemisphere lacks the ability to comprehend time, space, and motion, and struggles with conveying and interpreting emotions. It also has a limited grasp on the body and self, and is weaker in direct perception, evaluating beliefs, and making judgments. It is more prone to seeing the world through abstractions and representations, detached from the actual lived experience. The writer argues that the left hemisphere of the brain tends to be overconfident in its understanding of the world, while the right hemisphere is more in touch with reality and aware of its limitations. The overconfidence of the left hemisphere has historically led to the demise of civilizations and is currently causing problems in our society. The left hemisphere is like a computer, only focused on linguistic processing and lacking insight into reality. In contrast, the right hemisphere is more perceptual and grounded in the pre-conceptual world. Our reliance on language and the virtual world created by the left hemisphere has caused a disconnection from reality and a vulnerability to mental illnesses like schizophrenia. The solution proposed is to rebalance the contributions of the hemispheres and redirect our attention towards truly seeing and understanding the world. In part 2 of the book, the author plans to explore different paths to truth such as science, reason, intuition, and imagination, considering their compatibility with the functioning of the hemispheres. Thank you so much for watching this video. Your support means the world to us. If you enjoyed it, don't forget to give it a thumbs up and share it with your friends. We look forward to reconnecting with you in the next video for the continuation of the summary.